In this video, I'm going to introduce the concept of waves. So let's start off with just kind of defining what a wave is. A wave is a disturbance traveling through some media. And as this, what we call a wave, travels through this media, it displaces particles up and down of the media. So for example, an ocean wave displaces particles of water vertically up and down as the wave passes through the water. Or in the case of like a sound wave, the sound wave vibrates the particles of air back and forth as the wave moves from one location to another through whatever medium it's in. But the important thing to know when we think about waves is that although the energy of the wave is moving from one place to another, it doesn't actually move matter. So, what causes a wave? So a wave is generated by a vibrating object, and the waves that are generated by that object travel away from the object. So you might think about if you shake a slinky, you're oscillating the slinky back and forth, and the waves are traveling away from you, the wave generator. It's important to know that the particles of the medium vibrate about a rest position at the same frequency as the source that you're vibrating. So if you're vibrating a slinky, the particles of the wave that's moving through the slinky will vibrate at the same frequency that you are moving the slinky back and forth. The last thing that you definitely need to remember, I've mentioned it before, but it's important to remember that waves transfer energy from one place to another, not matter. The particles of the wave will stay in place and vibrate about the same rest position, but the wave's energy will move from one place to another. Okay? There are two fundamental types of waves, and we can classify them by the type of media which they can move through. So the first media, the first type of wave is called a mechanical wave. And these are waves that require a media for them to travel from one place to another. So mechanical waves require a media, like I said, and what I mean by medium is for example, an ocean wave's medium is water. A sound wave's medium is air. So something made of particles that the wave can vibrate back and forth as it moves through that substance. The other type of wave is an electromagnetic wave. And this type of wave, unlike a mechanical wave, can travel through a vacuum. So electromagnetic waves are like light waves. So light can travel from the sun. It can travel through empty space, a vacuum, where there is no medium for it to disturb, and make it to Earth. Electromagnetic waves, unlike mechanical waves, can travel through a vacuum. The other way we can classify waves is by the relationship between the disturbance which creates the wave, or a pulse, and the direction the wave travels. So if you have a wave that could be classified as a transverse wave, the direction of the pulse which generates the wave, this disturbance right here, which is going up and down, is perpendicular to the direction that the wave is traveling. The next type of wave that we can classify by the relationship between the direction of the disturbance and the direction the wave travels is called a longitudinal wave. And as we can see here, this is an example using a slinky wave. The direction of the disturbance is now parallel to the direction my wave is traveling. So my wave is traveling this way, and the direction of the disturbance is in the same direction as the wave is traveling back and forth. Longitudinal waves are different from transverse waves because they create bunches and stretched out regions of the media they travel through. We call the regions of the media that are getting pushed together, we call compressions. We call the regions of particles that are getting pushed apart rarefactions. Probably one of the most common examples of a longitudinal wave is sound. Sound is made by the compression and basically the pushing and pulling apart of air molecules or whatever media the sound's moving through. So we can see this in how a speaker makes sound. So inside the speaker there's a membrane, And when the membrane pushes forward, it compresses the air together. And when the membrane pulls backward, that membrane that oscillates the air molecules in front of the speaker, and that propagates a wave through the air, which allows us to hear sound.